Hi, my name is Manish Dev. I'm Product Marketing Manager for high-end FPGAs at Altera. I'm here today with Jay Wallstrom, HMC Senior System Architect at Micron Technologies. Jay, thank you very much for joining us today.
Thank you, Manish. It is great to be here. I'm really excited about what we have planned to show people today and what it's going to provide system designers going forward.
Absolutely. Today, we will be demonstrating the industry's very first interop between Altera's Stratix 5 FPGAs and Micron's hybrid memory cube device. With this solution, system designers can evaluate the benefits of hybrid memory cube technology along with FPGAs and SoCs in addressing pressing memory bandwidth challenges.
That's right, Manish. The problem for memory architects has been how to get the desired bandwidth at the appropriate power. Then the details of routing hundreds of pins, board complexity, thermal dissipation, the list goes on and on and on. The hybrid memory cube is the answer to the limitations of traditional memory technology. This revolutionary leap in DRAM design provides up to 15 times the bandwidth, uses 70% less energy, and 90% less space than existing technologies. HMC simplifies and delivers a solution combined with the Stratix 5 architecture that enables designs today.
That's exactly right. The goal of the Altera and Micron teams was to showcase this technology early and enable our customers to start exploring use models for this technology today. By demonstrating Altera Stratix 5 devices and the hybrid memory cube technology working together, customers can leverage their current Stratix 5 devices and prepare for production deployment with Altera's Generation 10 devices, knowing that they will have proven HMC support. Why don't we take a deeper look now and see how this amazing technology actually works. The interop platform, which is what you're looking at here, is the size of an ATX card. An Ethernet cable from the PC is used to communicate instructions to the FPGAs to perform exercises that demonstrate the bandwidth of the hybrid memory cube device. The I2C is used as a sideband communication channel to collect the status of the hybrid memory cube device. As you can see here, the hybrid memory cube device is sitting right in the center of it all, mounted on a test socket. There are 4 Stratix 5 FPGAs that are located on the corners of the platform. Altera Stratix 5 FPGAs are capable of supporting transceiver data rates of up to 14.1 gigabits per second. Jay, is there a particular rationale for the way the setup has been configured?
Great question, Manish. Each FPGA is attached to an HMC link. Each link has the capability of 40 gigabytes up to 60 gigabytes of total bandwidth. In this configuration, a system designer can emulate the traffic of 4 different devices in a shared memory configuration, or emulate traffic patterns of a single host device accessing the HMC memory. This is very useful for an engineer who wants to determine bandwidth capability with traffic patterns that represents their end applications.
That's really interesting. Why don't we get straight to it and show the actual demonstration itself?
So this is the display GUI as we're running with the FPGAs on the board. In our display GUI, you'll notice that there's a number of different bytes. These are 128 bytes, 16 bytes, 32, 64 bytes. Each one of those represents a data packet size we can choose. In this case, we're going to choose 128 bytes. When we look at the 128 bytes underneath there, there's a couple of numbers there, 0, 100, 100, 0, 50, 50. This represents read-write ratios. We're going to choose 50, 50. What that'll do is that'll do a 1-to-1 read-to-write ratio. As we move on down to the bottom, you see that there's link 0, 1, 2, 3. Each one of these links is attached to an FPGA talking to one of the links of the HMC device. And what you'll notice is a blue line, which is read, a red line, which is write. And if you can see off to the side, 16 gigabytes of read, 16 gigabytes of write. That aggregated up, if you pan up to the top screen, you'll see the aggregation of all that equals roughly 130 gigabytes per second of data bandwidth. The incredible proof point is the aggregate bandwidth you can achieve with one HMC device, roughly 130 gigabytes per second bandwidth. That removes the memory bottleneck, enabling 1.2 terabit bandwidth applications. If we had additional time for the demo, we could demonstrate server and storage applications where this would exhibit read-heavy or write-heavy requests respectively. But unfortunately, Manish, I think we're out of time.
That's right, Jay, but that was definitely impressive. You have Altera's proven transceiver technology on one end and the hybrid memory cube technology on the other, all working together to put our customers at the very forefront of technology innovation. Altera will have full production support for the hybrid memory cube technology, starting off with the Generation 10 product portfolio, which includes the Area 10 and Stratix 10 FPGAs and SoCs. As you can see, the Generation 10 portfolio will feature significant power and performance gains relative to previous generation, feature embedded on processors as well as 3D technology. In fact, Stratix 10 FPGAs and SoCs built with state-of-the-art Intel's 40nm Tri-Gate process will feature the industry's very first gigahertz FPGAs. You're talking about some serious performance here. With 96 to 144 transceiver channels, capable of running at data rates ranging from 28 gigabits per second all the way to 32 gigabits per second chip to chip, you will have more than enough firepower to interop with the HMC and meet your system goals. For more information about this technology or to track ongoing developments, feel free to visit the Altera homepage at altera.com or Micron's homepage at micron.com. Finally, to summarize, you've just seen a live demonstration of Stratix 5 devices showing incredible bandwidth with the new hybrid memory cube devices. This platform is available for demonstrations today. And don't forget, with Altera's Generation 10 portfolio, which includes Stratix 10 and Area 10 FPGAs and SoCs, customers will have full production support for the hybrid memory cube technology.
Yes, Manish, this demonstration should retire the myth that memory is the bandwidth limitation. Stratix 5 and HMC delivering the right bandwidth at the right power.
That's exactly right. My name is Manish Dev from Altera's high-end product marketing team.
And I'm Jay Wallstrom, Senior System Architect at Micron.
Thanks for watching.